students. So today let us see a few examples from the second exercise of the chapter Relations and Functions. So please open the textbooks, open the second exercise of the chapter Relations and Functions, and let me solve few examples from those. Now yesterday we solved few examples, right? We saw how the domain and codomain matters. We saw a function f from natural numbers to natural numbers, which was defined as f of x is equals to x squared. We saw that that function is 1, 1, but it is not all. But if you take domain and codomain as set of integers, then the function was not at all 1, 1, 1 as well as it was not 1. Now let us see the fourth question. I hope you all have textbooks. You all have textbooks, students? Yes? Let us look at the fourth question. The fourth question says that show that the modulus function f from set of real numbers to set of real numbers given by f of x is equals to mod x is neither 1, 1 nor on 2. Where mod x is x if x is positive or 0 and mod x is minus x if x is negative. Already we have this modulus function, right? Is everyone with us? So already students we know what is modulus function, right? We also saw the graph of the modulus function. So how was graph of modulus function, right? This was positive x-axis, negative x-axis, positive y-axis, negative y-axis. So how does the graph of modulus function look like, students? It was in this form, right? In the shape of V. We also saw what is the domain of this modulus function and range of the modulus function. I hope you all remember. What is the domain of this modulus function? Yes? What is the domain of this modulus function, students? Domain is nothing but, very good, it is set of real numbers, right? Here only we have domain of the modulus function is set of real numbers. Codomain is also set of real numbers. But can you tell me what is the range of this modulus function? What is the range? What is range of modulus function, students? I hope you all remember. We all have studied how to find the range. I already told you range you have to see through y-axis and domain is through x-axis. So what is the range here? Please mute yourself, everyone. Yes, what is the range here, students? Can anyone tell me? What is the range? I hope you all remember, right? What is the range of the modulus function? By looking at the graph, you can tell it. Just look through y-axis. Where is the graph? Yes, anyone?
Negative integer.
Non-negative integer, very good. Here you can observe the graph is starting from 0, it includes 0 and it is moving towards positive y-axis. So my range is equal to, it includes 0 and goes to positive infinity. So this is my range. Close 0, close into and goes to infinity. Please mute yourself. So this is nothing but non-negative real numbers. Non-negative real numbers. So this is my range of the modulus function. Now we want to check whether this is 1, 1 and or 2 or 4. So tell me students, is the function 1, 1? Is this function 1, 1? Already they have asked us to show that it is neither 1, 1. So this is not a 1, 1 function. Can you give me the reason, students? Can you give me reason? What is 1, 1 function? It is nothing but different elements in the domain should have different units in the codomain. Right? Here you can observe we have 1, minus 1 belonging to set of real numbers such that f of 1 is equal to f of minus 1 which is equal to 1. Please see carefully, students. We have two real numbers 1 and minus 1 such that the images are same. See, if you take f of 1, what is f of 1? It is nothing but mod of 1. What is mod of 1? It is nothing but 1. If you take f of minus 1, what is f of minus 1? Please mute yourself. What is f of minus 1, students? It is nothing but mod of minus 1. And what is mod of minus 1? It is again 1. So you have two real numbers. You have like that, you have many real numbers. I am just taking one example to show it is not a one-one function. To show it is not a one-one function, you just need one example solved. But if you want to show that it is one-one function, that should be true for every element of the domain. But here you can see we have two real numbers 1 and minus 1 such that their images are same, right? F of 1 is equal to f of minus 1. But you can observe that 1 is not equal to minus 1. So this condition failed. If you suppose f of a is equal to f of b, that should imply a is equal to b, right? This was the condition to show that the function is 1, 1. But here you can observe we have two elements a and b, that is 1 and minus 1 in domain such that their images are same. F of 1 is equal to f of minus 1. But what you can observe, students, you can observe that 1 and minus 1 are different elements. You suppose this condition, if you consider this condition, f of a is equal to f of b, but you came at the conclusion that a is not equal to b. And hence you conclude that the function f is not 1, 1. The function f is not a 1, 1 function. So whenever they ask you about the modulus function, students, you can tell that this function, modulus function, is not a injective function. Or you can say it is not a 1, 1 function. So did you all understand how the modulus function is not a 1, 1 function? Yes, students? Is it clear? Now tell me. Now they have already told that it is not onto also. Can you tell me the reasons, students? Please, I want reasons from you all. Why the function is not 1 onto? Because it is not surjective. They have already told that it is not surjective. They have asked us to show that the function is not surjective. Can you tell me the reason why the modulus function is not an onto function? Very easy. So to check whether the function is onto or not, you need to check whether every element in the codomain is the image. Or you can say that every element in the codomain has a pre-image. Or one more definition we have, if range is equal to codomain, then you conclude that the function is onto. Now tell me why this function is not an onto function. Can you give me the reason?
So codomain is not equal to its range.
Very good. Already we saw that what is the range of this modulus function? Range is equal to 0, infinity. That is non-negative real numbers. It includes 0 and goes to positive infinity. But what is a codomain, students? Codomain is nothing but set of real numbers. It includes negative real numbers also. Right? So here you can say that range is not equal to my codomain. Because range is nothing but set of non-negative real numbers. But what is my codomain? It is an entire set of real numbers. And hence, range is not equal to codomain. Therefore, the function f is not an onto function. Function f is not an onto function. So this function, modulus function, it is neither one-one function nor onto function. And hence, you can conclude that this function, modulus function, is not a bijective function. Is that clear? Any doubts in this, students, in this problem? Did you all understand this? How to show injectivity and surjectivity of a function? Now let us see the next example. Fifth question. The fifth question says that show that the signal function f from set of real numbers to set of real numbers given by f of x is equal to 1 if x is greater than 0, 0 if x is equal to 0, and minus 1 if x is less than 0. Yes, students. I hope you all know this signal function, right? Do you all know this signal function, students? I hope you have learned this in first PUC. Signal function. And also the graph of signal function, it looks like so this is my 0 and suppose this is my 1. This is my minus 1. Very good. See here, students. My signal function looks like here we don't have anything. This is a blank dot. Here again the graph comes. So here it is again a blank dot and it continues. I hope you all know this, right? The graph of signal function looks like this. So how it is defined, students? For all values x greater than 0, means for all positive real numbers, the value is equal to 1. For x is equal to 0, the value is equal to 0. And for all negative real numbers, the value is equal to minus 1. So here you can see for all, this is my domain, right? Set of values. So for all negative real numbers, the function value is equal to minus 1. But at 0, it is 0. So here we have a blank dot. At exactly 0, the function value is equal to 0. So here we have a blank dot and here we have a full dot. Again at 1, it is blank dot and it goes for all positive real numbers, the function value is equal to 1. So this is my graph. By looking at the graph, you can observe that range is equal to only 3 numbers, 3 real numbers. What are those? It is minus 1, 0, 1. So my range is equal to minus 1, 0, 1. It includes only 3 real numbers. I hope you all know this, right? Signal function. Okay. Now we have to check. We have to show that it is neither 1, 1 nor a 1. So let us see how it is not a 1, 1 function. So can you give me the reason, students? Now already we saw one example to show how it is not 1, 1 or how it is not a 1. Now can you tell me how this function, signal function is not a 1, 1 function? Can you give me the reason? Why the signal function is not a 1, 1 function? Yes? Anyone?
A is not equal to B.
Very good. A is not equal to B. Means I can take two real numbers from the domain. I can take 1 and 2. Okay. So these both are positive numbers. You can observe this. I have taken two real numbers from the domain 1 and 2. You can observe these both are positive real numbers. Now can you tell me what is f of 1 equal to and what is f of 2 equal to? F of 1, how the function is defined? For all positive real numbers, the function value is 1. For all negative real numbers, function value is minus 1. And for at 0, function value is 0. So here you can observe 1 is a positive real number. So f of 1 will be equal to 1. F of 2, now 2 is again a positive real number. So f of 2 will be equal to 1. So here you can observe we have two real numbers from the domain such that their images are same. Their images are same, but 1 is not equal to, means we have two real numbers from the domain such that their images are same, but the two real numbers are different. Hence the condition for injectivity fails. And hence you can say that this function, signal function, is not a 1, 1 function. So you can take any one example to show that the function is not a 1, 1 function. I have taken two real numbers 1, 2 from the domain. You saw that their images are same because for all positive real numbers the function is defined as equal to 1. So if f of 1 is equal to f of 2, but you can observe that 1 is not equal to 2. So the condition of conjugative fails and you can conclude that the function is not a 1, 1 function. The function f is not a 1 1 function. Is that clear? Did you all understand, students? Now tell me why it is not an onto function. Why the signal function is not an onto function? Students, you should be knowing what is this signal function, okay? How it is defined. Also, you should know what is modulus function, what is greatest integer function. If you know how it is defined and how it works, and also if you know the graphs of this particular function, then you will be able to solve the problems very easily. First of all, you should be very perfect with these graphs. By just looking at the graph, you can answer many of the questions. Now, can you tell me why this function is not an onto function?
Domain is not equal to its range.
Very good. What is range? We already saw that range by range is equal to three elements, set of three elements. It contains -1, 0, and 1. I hope you are getting the range. Right? Here you can observe on y-axis, graph is only on this -1 number at 0 and 1. And hence the range includes the set of three real numbers -1, 0, and 1. But what is the codomain, students? Codomain is the set of all real numbers, right? So you can observe that my range, which contains three real numbers, is not equal to my codomain, which is the set of real numbers. And hence you can conclude that the function f is not an onto function. So this signal function is also not an one-one function, and it is not an onto function. And hence you can conclude that the function f is not a bijective function. So I hope you all have understood how to show whether the function is 1 1 or not, or onto or not. Is that clear to everyone? The examples which I have left out from the exercise, you need to solve it on your own. Will you be able to solve it, students? Yes? I hope you are able to hear me. Will you be able to solve the remaining problems which I will be giving? Let us see few more examples from this exercise. Now look at the ninth question, students. They have given a function f from set of fraction numbers, and it is defined by f of n is equals to n plus 1 by 2 if n is odd, and n by 2 if n is even, for all n belonging to set of natural numbers. For all n belonging to set of natural numbers. So we have to state whether the function is bijective or not. So here you can observe, students, how the function is defined. It is defined from set of natural numbers to set of natural numbers, and it is defined in two ways. If n is even, then it is defined as n plus 1 by 2. And if n is odd, if n is odd, it is defined as n plus 1 by 2. And if n is even, it is defined as n by 2. Now we need to check whether this function is 1 1 and onto or not. Bijective means the function should be both 1 1 as well as onto, right? So let us check. Can you tell me whether the function f is 1 1 or not? Is the function f 1 1? It is not visible. Okay, I hope now it is visible, right? The function f is defined from set set of natural numbers to set of natural numbers. It is defined by f of n is equals to, if n is odd, it is defined as n plus 1 by 2, and if n is even, it is defined as n by 2, for all n belonging to set of natural numbers. Now tell me whether this function f is 1, 1 or not. Yes, students, can you all tell me whether the function f is 1, 1 or not? 1, 1 means either you check by the definition that every element in the domain should have different every different element in the domain should have different image in the codomain. Or else you can even check it that by verifying that condition. What is that condition? You just consider f of a is equals to f of b, and if you are able to prove that a is equals to b, then the function is 1, 1. Or else you can say that the function is not a 1, 1 function. Now, by looking at this function, how it is defined, can you all tell me how whether it is 1, 1 or not? Try to solve
Is
it.
1 1 function.
Yes, very good. It is 1, 1. Sorry. Please check, students. Take any two elements from the domain and find their images such that their images are same, and see whether the two elements are same or not. Please apply your mind here. It is not a 1, 1 function. Just take two elements from the domain such that their images are same. Now here I shall take 1 and 2. Okay. My domain is set of natural numbers, right? I have taken two elements 1, 2. Now can I tell you what is the image of f of 1? Now 1 is an odd number. 1 is odd. If n is odd, it is defined as n plus 1 by 2, right? So 1 is odd. So f of 1 will be equal to 1 plus 1 by 2. 1 plus 1 by 2 is 1. Now what is f of 2, students? Now 2 is an even number. If n is even, it is defined as n by 2. So if 2 is even, so it is defined as 2 by 2. What is 2 by 2? It's again equal to 1. So here we have two elements from the domain such that their images are same. We have two elements in the domain such that their images are same. But the two elements are not same. Two elements are different. Hence you can say that this function f is not a 1, 1 function. You should be very careful, students. Then you can observe that if I take two elements from the domain 1 and 4, what will be f of 1 equal to? Since 1 is an odd number, f of 1 will be equal to n plus 1 by 2, right? What is n? It is 1. So it will be 1 plus 1 by 2, that is equal to 1. And what will be f of 2 equal to? Since 2 is an even number, f of 2 is defined as n by 2, that is 2 by 2. So f 2 by 2 is equal to 1. So I have two elements from the domain such that their images are same. But we can observe that the two elements are different. And hence you can conclude that the function f is not a 1, 1 function. The function f is not a 1, 1 function. I hope you understood, students, how it is not a 1, 1 function. Did you understand? Is there any doubt? Yes? Everyone, did you all understand? Okay. Now let us see whether it is onto or not. To check onto, we have three definitions with us. Either you check whether every element in the codomain is the image, or else you can say that every element in the codomain has a pre-image. Or you can even check it by seeing whether range is equal to codomain or not. Now let us check that this function is onto or not. But here, students, you can see we have two cases. We have case 1 when n is odd, and we have case 2 when n is even. Let us see in both the cases. Case 1. What is case 1? If n is odd. If n is odd, let us take only this case. When n is odd, the function is defined as n plus 1 by 2. Now if n is odd, can you tell me what will be my range? Yes? If n is odd, can you tell what is the range, students? Means you need to check every, now right, so n means it starts from natural number, right? So it starts from 1. Now take all the odd numbers one by one and see what range you are getting. Means what images you are getting, you see. So the range will be collection of all images. So if n is odd, can you tell me what will be the range? If n is odd, can you tell me what will be the range equal to? Yes? Yes, students. What will be the range if n is odd? I hope you all are able to solve. Take all odd numbers and see what are their images. Only few you take. 1, 2, 3. You shouldn't say just 1, 2, 3. It is a set 1, 2, 3 and so on. It goes to infinity, students. See, let us start from 1. What is f of 1 equal to? 1 plus 1 by 2. That is 1. Right? It is equal to 1. Now if I take f 3, next odd number. If I take 3, f of 3 is equal to 3 plus 1 by 2. That is 4 by 2. And that is nothing but equal to 2. Now if I take 3, so sorry 5, next odd number. 5 plus 1 by 2, that is 6 by 2, that is equal to 3. If you take next odd number, that is f of 7. F of 7 will be equal to 7 plus 1 by 2, 8 by 2, that is equal to 4. And so on. So you can observe that if you take odd numbers, the function, the range is equal to 1, 2, 3, 4 and so on. So actually what is this? It goes to infinity. What is the set? What is this set called? Yes, students, what is the set called? Range is nothing but collection of all these elements. It starts from 1 and goes to infinity. If you see, if you take the next number, odd number f of 9, answer will be 5. So here again we get 5, then 6, 7 and so on. So can you tell me what is this set? Please answer quickly, students. Very good. It is set of natural numbers, right? So when n is odd, my range is equal to set of natural numbers. Now can you tell me whether it is odd or not? When n is odd, only we are saying in the case of when n is odd, when it consists of all odd numbers. In case 1, my range is equal to a set of natural numbers. Is this function onto when n is odd? Yes? Is the function onto? The answer is in front of you all, right? Why are you not able to answer? Please students, be interactive in the class. See here, we are talking with respect to only case 1, that is if n is odd. Now whenever we are taking odd numbers, we have got the collection of all images as 1, 2, 3, 4 and so on. So this range is equal to set of natural numbers. So here you can observe that my range, that only we are talking with respect to this case when n is odd. So in this case, my range that is equal to set of natural numbers is equal to my codomain. My range is equal to my codomain. And hence you can conclude that the function f is onto function when n is odd. So if you consider case 1 where n is odd, if you go on taking all the odd numbers from starting, you can see that my range is the collection of all natural numbers. You get 1, 2, 3, 4 and so on. So all the natural numbers are my images. Right? So here you sorry. So here you can observe that my range is equal to codomain. And if range is equal to codomain, you can conclude that the function f is odd. Now if I consider the second case, that is when n is even. When n is even, second case, what will be my range equal to? Yes? If n is even, what is the range equal to? Now go on taking even. See, this case you will consider now. Go on taking even natural numbers. Tell me the function values. See what all images you will get. And tell me what is the condition. Very good. Zainabi, please send the message to everyone. Don't send it privately. So that is the right answer. Range is again the set of all natural numbers. See here. Now if I take even natural numbers, what will be first even natural number? It is 2. So what will be my f of 2 equal to? Since it is even, it is defined as n by 2. So f of 2 will be equal to 2 by 2, that is equal to 1. Let us take the next natural number, even natural number, that is f of 4. F of 4 will be equal to 4 by 2, that is equal to. If I take f of 6, next even natural number, f of 6 will be equal to 6 by 2, that is equal to 3, and so on. You get all the natural numbers only. So range is equal to 1, 2, 3, 4, 5, 6 and so on. So what is this set? This set is nothing but set of natural numbers. It is set of natural numbers. And hence you can say that in this case also my range is equal to codomain. Because my codomain is again a set of natural numbers, right? So hence you can say that range is equal to codomain. So in both the cases, you can conclude that function f is onto function. In both the cases, when n is odd and also when n is even, you can see that range is equal to codomain, and hence you can conclude that the function f is onto function. The function f is an onto function. Is that clear, students, to everyone? Is this problem clear? Did you all understand? Yes? Did you all understand, students? Okay. Now let us go to the next example. Let us see the next example. Very important example. 10th one. Let A is equals to set of real numbers minus 3 and B is equals to set of real numbers minus 1. And the function f is defined from A to B. Okay, how it is defined? It is defined as f of x is equals to x minus 2 divided by x minus 2. So see here, students. Here set A is nothing but set of real numbers minus 3, means it contains all the real numbers except 3. And my set B contains all the real numbers except 1. The function f from A to B is defined as f of x is equals to x minus 2 divided by x minus 3. Now we need to check that it's 1 1 and 1 over. No. So let us check it generally, students. Why? Means it is a general arbitrary function, right? So let us check it generally. So to check 1 1, what we will consider? We will consider two elements from the domain such that their images are same. So let me take that A comma B belongs to my capital A such that f of A is equal to f of B. So I have considered two elements from the domain A such that the images are same, that f of A is equal to f of B. Now if function is defined like this, a minus b. F of b will be equal to b minus 2 divided by b minus. Now solve this, students. Cross multiply and tell me what answer you will get. Cross multiply. You just multiply these two polynomials and tell me what answer you will get at last. Please, everyone. What answer is left at last? If you solve these two by cross multiplying, what answer you will get? Yes? A minus 2 into b minus 3. This and this, multiply. Next, a minus b into b minus. Multiply these two. So if you multiply these two, what you will get? A into b, ab, minus 3a, minus 2b, plus 6. ab, minus 2a, minus 3b, plus 6. So from both sides, ab is cancelled. 6 is cancelled. Right? If I take this minus 3a on the other side, see. So what all is remaining? Minus 3a plus minus 2b is equals to minus 2a minus 3b is remaining, right? This is remaining. Minus 3a minus 2b is equals to minus 2a minus 3. I take this minus 3 on the other side and take this minus 2 on this side. So it will be 3b minus 3 will become plus 3b minus 2b. And minus 3a if you take on the other side, it will become plus 3a minus 2. 3b minus 2b is nothing but b. 3a minus 2a is nothing but b. See, students, Zainabi, I hope you understood this. You should cancel very keenly. The science students should be very careful with this signs. When you multiply, you get this. So AB on both sides will be cancelled. 6 on both sides will be cancelled. So these things are remaining. I have taken this term on the other side. So if you see that, you will get the answer B is equals to A. So you had considered two elements from the domain such that the elements are same. And you concluded that the two elements are equal. That is A is equal to B. So thus, what you can conclude? You can conclude that the function f is a 1-1 function. A function f is 1-1 function. We have only 2 minutes left. So tell me, students, did you all understand? Zainabi, did you understand? These steps, did you all understand, students? You have considered two elements from the domain such that the images are same. You solved, simplified that equation and it came at the conclusion that A is equals to B. And hence you can see that the function f is 1-1 function. So I hope you all understood this. How we showed that the function is 1-1 function. Now please students, you have to check whether this function is onto or not. Generally. Generally means you just take one element from the codomain, general element, and then you in return you need to show that we have one element in the domain such that f of a is equals to b. So you need to check that. So as our time is up, I will end with this. I want you all to solve on 2, subjectivity. Check for subjectivity. Check whether this function is surjective or not. Please, I want answer from your students in my next class. We'll continue with this example. So, this ended my today's class here. Thank you all. Have a great day.